Go.
Hello, everybody. Welcome and thanks so much for joining us today. We're excited to have you here. First, a couple introductions. Gary, our CEO, Natalie, who is our senior account manager, Dave, who's a senior engineer, and myself, just principal consultant here, co-owner with Gary. First, a couple quick notes before we jump in. Everyone's lines are muted for now, but we will open them up during the Q&A. And if you have any questions along the line, we have a Q&A, so drop them in there or, um, we'll keep an eye on it. So if there's any questions that are pertinent, we'll get them asked and answered. If you raise your hand, we'll also see it as well. When we wrap up, we'll send you a couple surveys through this process and get some feedback. Anyway, let me introduce you, Gary, our CEO of BluWave Consulting Group. Gary, it's all yours.
Thanks, John. One more item to talk about is that we have this QR code available for if you would like help from the BluWave team. You scan that and you'll get a few questions that will alert folks that, hey, I would like help with my AI. And we'll also put the link for it in the chat. Okay, so to start off with, oh, hang on a second. One thing really quick. So just to kind of talk through the agenda. So what we want to do is we want to go through the maturity model, an AI maturity model, kind of similar to the common maturity model, CMM. And then we're going to talk about 2026 developments. Then we'll do a little Q&A session to break things up a little bit. Then we will go into the Microsoft space, the Microsoft ecosystem, and talk about what Microsoft is doing in the AI space. And then we'll kind of go through kind of the top models as we see them in the current state. We'll provide an example of AI and human collaboration, and then a demonstration of a full multi-agent system that we're calling Project Agency. And then, as stated, we'll open up for Q&A and do questions and answers after that. So, in talking about AI maturity, what we want to do is have folks take a look at this particular graph here and see kind of where you are in this, right? So there's these different levels. The first level is probably where a ton of people, a ton of organizations are at this time, which is chatting with an AI model, right? So like your ChatGPTs, your Claudes, your Geminis, those types of things, and basically helping them with writing emails, helping them answer questions, plan trips, things along those lines. The next level is where essentially you start to deal with AI agents. Now, what is an agent? An agent is an AI model like a ChatGPT or a Claude or whatever, and you start to give it tools and it's actually starting to do work. And we'll give you an example of that later on as to how we've set up an AI agent in order to interact with our systems and talk about the systems that we have it interacting with. Then the next level is multi-agents and essentially having a system of agents where then the human becomes more of a supervisor, and that's where the agents handle most of the work themselves, and then the human becomes a human in the loop, approving the final result of that process. And then finally, which this is kind of where people get a little bit concerned, is the self-improving, self-sustaining agents, where essentially it becomes kind of their own life cycle ecosystem by themselves, right? So the level that we're at today is we're kind of between level 2 and level 3. We're working in these spaces. I wouldn't say we're full level 3 yet. I say we're essentially working in the level 3 space. and working with multi-agent systems. We haven't gotten to the always on stage. So I would say probably 2.5 is kind of where I would put us at this point. So let's talk about why 85% of companies are failing at AI agents. I actually just read Tech News. There is an article here from Deloitte, essentially, that's talking about as organizations are moving into production, they're struggling. So let's talk about that for a little bit. And you've probably have heard the things. There's been a number of statistics, either between 85 and 95% of AI initiatives don't get out of the pilot phase. Why? Because an AI agent, an AI model, or an AI agent is a probabilistic system. Now, as opposed to a deterministic system, like for example, a good deterministic system is a light switch. I flip the light switch on, the electricity goes on, the light goes on, and that happens every single time. It's the same thing every time. Flip it on, flip it off. A probabilistic system, in a different sense, is it is not the same outcome every single time. And so AI models are a probabilistic system. You can think of ChatGPT and those items as a sophisticated prediction engine. And if you think about it, you do hundreds of thousands of predictions. You're not going to get based on probability, you're going to get the wrong answer some of the time. And this is where these hallucinations come from. AI models basically make things up because that's what they're programmed to do. And this is one of the major issues that happen with AI models. So what they're finding is that essentially you must have harnesses, and what people are talking about for 2026 is focusing on the work on the harness, because through 2023 to 2025 they've worked on the model, and they've made the model smarter. ChatGPT 5.2 is smarter than ChatGPT 3 by many orders of magnitude. Moving forward, now the focus is going to be on how do you take the model that we have today, because we don't think we're going to get, much. Some people don't believe that we're going to get way better models than what we have today, but that the models are pretty much where they're going to be, because the amount of resources associated with getting from, let's say, 90% to 95% or 97% is so astronomical from a systems engineering perspective, it's not going to be possible. Okay, so then what do you do? So what you do is you provide a bunch of other additional helper parts and to the model to help keep it in line, right? So things like tools for specific use. So instead of giving the model access to all your systems and saying, go figure this out, you give the model one particular tool for one particular use, and that then goes and gets the information that it's looking for and provides that to the model, because models tend to get confused when there's a lot of different tools available to it. You also provide structured inputs and structured outputs to say that here's the information coming in, it has a specific structure to it. And then to the model, you tell the model, I want this out of it every single time. Don't do anything else. Do this particular, and you kind of force it into that. You also have grounded sources, and you'll kind of see this with Google. If you work with Gemini, Google will have a Gemini option for you to ground your results with Google search, so that when Gemini finds something, it's forced to create citations, and that will help the model to not make things up. There's also policy checks, permissions, audit trails. And this shows up in what people are now calling contracts. So, and what you'll see with our system is that the master agent will create a contract for the particular project that's being laid out. And then all the agents in the system will then uh, build to that contract, the reviewer will review to that contract, and the whole thing will be evaluated based on that contract. Then there's evaluation and monitoring of the whole system. So all the multi-agent systems, and then also having the whole process afterwards evaluated by a model. This is called a model as a judge. And there's actually a really great example of this that just came out. One individual that's well known in the space created a panel, a board of models that essentially think of like Claude, ChatGPT, Grok, Gemini, and essentially as a panel of models. And the way it works is you pose a question, the model gives an answer, the answers are anonymized, the models then vote on the best answer, and they are surprisingly objective, meaning that they will often vote for another model's answer because it's a better answer. So what they're learning is that the key to success is don't try to prompt your way into certainty. It does not work in production. And you're finding that out, right? Because essentially you get these stories where the model is brought into production and it goes off the rails and promises the farm to somebody somewhere, right? So design an architecture with contracts, reviewers, and also we recommend the human in the loop, at least at this time, for the final approval of things. Don't let the agents go off by themselves if there's any significant impact if they get something wrong. Make sure that there's a human in the loop for the final step. My favorite quote about this is that a probabilistic system without guardrails is a slot machine. And then when you provide it constraints and guardrails, it becomes reliable and can complete work. So we're talking about the harnesses and or scaffold. And another thing that they're finding now is that when you have, they just did a research paper that talked about this, is that when you have a mid-tier model with a strong scaffold, it'll beat a top-tier model with a weak scaffold. So the smarts, it's no longer going to be focused on getting the best model. That's not the way to win. The way to win is to get a decent model and to build a strong scaffold around it. Now, the good news for that, right, is that you don't have to spend all your money on the model. You can reduce the cost associated with the model by doing a good mid-tier model, and then from there, building out the rest of the pieces in order to help make the model successful. So let's pause for a few minutes for any questions and answers.
We've had a couple good questions and have been answered.
You want to just go over some of those?
Uh, we had one question asking about the good use case for level 3. And we basically pointed out the fact that the demo is on that border. And with our feedback loops, we'll be able to demonstrate that pretty well. And we can talk about during the demo, we'll make sure we talk about how do we progress that into the level 4. So let's go.
Okay. Thank you for your questions. Appreciate that. Anything else? And was that it?
Yeah, that's it. Okay, there's a couple more coming in, but let's just get
Okay.
going.
Yeah, we'll keep going. I wanted to put in the chat for everyone the link if you would like help. I showed the QR code earlier, and we'll go back to that. But if you want, the link is in the chat for that. It's just a couple of questions, and then that'll uh, get you queued up for getting some help. All right. So, in dealing with the Microsoft space, right? So now we're gonna shift to how Microsoft is implementing their AI enablement. And so what they have done is they have provided three tiers, and I'm pretty sure that well, we know that there's a lot of information out there, a lot of news about the confusion around Copilot, right? So Microsoft 365 Copilot, then there's Copilot Studio, and then there's GitHub Copilot, and there's other ones that have Copilot, and it's very confusing. So basically, uh, in a nutshell, the Microsoft 365 Copilot is the chat. That's the one that everybody has access to. There's no additional cost associated with this. Microsoft is putting in everywhere, the Windows, Office, everywhere you can find a Microsoft product, it must be Copilot, Copilot this, Copilot that. You can think of that as similar to ChatGPT or Claude or Gemini or one of these other ones. The second level is the Copilot Studio, and this is a low code, no code type of situation, essentially where um, the way that you get a workflow done is put a bunch of objects together and add the connections for them, and then out of that you can add an AI component to that, and you'll have AI agent workflows without a whole heck of a lot of strong coding that's involved. A common example of that is N8N's um, system, or a Zapier or a Make, something like that, where basically you're just kind of taking parts and tying them together and then providing the glue in between them. Then the final situation that Microsoft has is the Microsoft Foundry, which is your full code environment. And essentially, as you move down the stack, at the top of the stack, it's very easy to talk to Microsoft Copilot chat. Getting down the stack requires more and more technical skill. But at the same time, what you also get with that is more control. So if you take a look in the AI agent space, you'll see Pedantic AI, LangChain, things along these lines. There's a bunch of other frameworks essentially where people who are comfortable with working with full code can have full capability and full control over the AI agents. Now we have, with the project agency piece that we did, we've gone the full code route, so we would be involved in the Microsoft Foundry space. Now, recently, probably November, I want to say, I think of November, December 2025, Microsoft introduced a bunch of different elements in their space that we think is and the industry out there thinks is a great idea, which is essentially adding that governance layer, because that's one of the things that's been missing so far. The governance layer includes this Entra agent ID, which has to do with giving an identity to an agent just like you would a person in a company. So you can associate it with groups, you can apply policy, you have an audit trail, and essentially treating it as another entity in the Azure space, to where you can do all the things you can do right now with people in Microsoft space. Then there's the Entra Agent Registry, which is essentially the 411, or if you're been around for a minute, the yellow pages of the AI space. Essentially, it's the place where people can look up and see agent capabilities and find what it is that they're looking for. Then there's Work IQ, which is the intelligence space. This is the memory and the knowledge for the agent, things like this. And then Microsoft is also working with multi-agent orchestration and things along those lines. So in production, you need to have the answer to all these questions, right? What agents exist? Who owns them? What data and tools can they access? How are they monitored, evaluated, and updated? And this is Microsoft's attempt to help address those particular items. Now let's turn our attention to the models because we talked before about how all you need is a mid-tier model. You don't need the strongest model that's out there and a great harness. So talking about that, then taking a look at what is in the current space, and by the way, this changes regularly. We did this about a year ago, and almost everything was different in here. Right now, the king of the heap is Claude Opus 4.5, soon to probably be Opus 4.7. But if you take a look here, this is the price associated with it. So over to the right is more expensive, and this is the intelligence. Up is smarter. And the green box here is kind of where we want to focus our attention in terms of the mid-tier models. And so if you take a look, Claude Opus is way over here on the right-hand side, super expensive. So we just kind of remove that one from the picture, right? So this is the same thing. It's just removing it so you kind of get a better view. And if you take a look in this space, these are the models that you want to consider. Right now, it's Gemini Flash in this space is your smartest model with the least amount of cost, but some of these are good as well. And then when you deal with heavy planning types of things, then you're going to go to your GPT 5.2s and Gemini 3s. Now, my understanding is that Claude Anthropic, who makes Claude, has kind of taken a cue from this, and I think what we're going to see here in short order is that Claude 4.7, which they said is going to be 3 times cheaper, is going to wind up in this space as well. This one just shows the output compared to the intelligence. In the space, you've got basically Gemini 3 Flash is a good sweet spot. So, and you'll see out there's a lot of recommendations right now to have most of your AI agent work done with Gemini 3 Flash. So that's what we've spent a lot of time on. The other one that we're using because we have policy that basically says zero data retention, meaning that as soon as the model grabs the information, it deletes it, is GLM 4.7. That one is also shown to be a good, inexpensive, mid-tier model for dealing with agent stuff. And you'll see that kind of out there in the information in the news and whatnot. So then we want to turn to the examples. And so going back to the tier 2, which is the human and AI agent collaboration, here's a particular example. So we attached an agent and we used Claude. We used the Claude model because this was a little while ago. We used the Claude model for this one. What we did was we connected it to our Microsoft, so Outlook, SharePoint, Teams, and OneDrive, and we connected it to our CRM system, which is ConnectWise. And basically, this was a particular example where we had the AI agent. There's a follow-up for sales. Go ahead and find the draft in Outlook and provide a red flag analysis. And so go ahead, read the mail, provide the red flag analysis, give what's critical. So the AI agent basically provided some feedback saying, hey, there's some issues associated with this. Would you like me to create another draft? Yes, absolutely. Then there was kind of some collaboration of I believe what happened was that the AI agent created a new draft that removed all of the previous information from the conversation, and that's not what we wanted. We wanted it to continue the conversation. So I provided feedback to say, hey, let's go ahead and do a reply on it. So I said, okay, I'll create a reply. So then it created a reply in that, right? And So then going back and forth a little bit, then basically the AI agent created the final draft. I sent the final draft, and then the AI agent updated the sales record in ConnectWise. It created an activity saying that we sent an email. It created a follow-up in a couple of weeks, and then updated the information in the CRM. Now, notice one of the things that we didn't do is we didn't have the AI agent do it all by itself, because based on what we said before, right? And so here you go. Here's an example. This is another situation. This is what not to do. Here's a cautionary tale. And this happened just this last week, so it's very timely. So I had an interaction with an individual that I know where essentially one of their people had sent me a message, which I believe it may have been AI generated. And so I responded back. I said, "Hey, how are things going? We haven't seen each other in a while. Let's catch up." I immediately got this response back. And so, which is great in terms of response, but you can tell that AI was involved because it's poorly formatted, and there's just so much the issue. I have so much issue with it. And I was talking with some folks, and basically, uh, in order to, they were lamenting essentially that they're getting so many messages back that are poorly formatted, that don't have the information that they're looking for, that miss the point and stuff, because AI is being used and people are not checking the work from an AI. So that's a cautionary tale. Make sure that you do what we did, which is have the AI generate the draft, do the heavy lifting for you, but definitely review it before it's sent, because otherwise you're going to wind up with messages going out to your clients like this, or your coworkers, or your partners, or whatever. And this doesn't exactly instill confidence in in this person, right? Okay. So another break for Q&A. We have more questions.
All the questions have been asked so far in the draft. I think there are a couple interesting ones. Um, One has to do with the Entra agent ID and how it's going to evolve and what other companies are and how they're going to use it. If you want to talk to that real quick. We also got a question about Crew AI. Um,
Yeah. Yep. Crew AI is another one.
so if you want to touch on those two, then we continue.
Okay. So the one about Entra ID, going back to that one. What was that one?
How it's going to be used with other companies are all also looking at having a agent ID and how it's going to be used.
So basically the Entra agent ID, I believe the question is getting to what we want to do is we want to be able to register, we want to be able to have our any type of agent in there, right? So for example, whoever brought up Crew AI, things along these lines. And our understanding is from Microsoft, which in my opinion is the smart way to do this, is that any agent can go through and have the agent ID. In the Microsoft space, if you build something in Copilot Studio or Foundry, it will automatically get an agent ID. But if you don't build it in using those platforms, then you can register it with Entra Agent ID and then the agent registry.
Cool.
And then what was the other one? Crew AI.
Yeah.
Crew AI is another AI platform. We haven't done things with Crew AI ourselves. We're using Pedantic AI at the moment, along with LangChain and LangGraph. However, Crew AI is definitely something that other organizations are using and are having success with.
Okay, let's continue.
Okay. Okay, so now we provided an example in the tier two space. Now we want to provide an example in the tier three space. And this is the multi-agent system. And so basically this is our project agency. And let me make this a little bit bigger. If I can. I don't think I can. Okay. Never mind, I can't. Um, the this is and with the multi-agent system, what I wanted to point out is uh basically all the different types of things that we've done with this system in order to get a desired result. So what this is it's a system where you create a specification, which by the way, you can hand to AI, and I'll give you an example. So it's called a product requirements document. And what we'll typically do is we will either take a transcript from a meeting where we've had a conversation with a client, and we will then uh, put the transcript through one of these processes in order to create a product requirements document. Now, here's the types of things. This is an example product requirements document. Basically, provides a summary, problem statement, goals, scope, what's in scope, what's out of scope. You could, if you're familiar with use cases, it deals with use cases or user journeys, and then it defines specific requirements. In any enterprise organization, you'll have these types of things. These are specifications or um, design documents, things along these lines. And so it'll provide all this detail about it, including, kind of like what the next steps are, deal with security, all these types of things. And so what you can do is you can just kind of describe to an AI what you want. You can either type it in or you can do a voice chat and basically connect with the AI and say, okay, now I would like a product requirements document or a PRD. All of them know what this is. They've all done a great job at creating it. And so then you create that product requirements document. Uh, then so then we have the product requirements document and we put it into the system. It goes into a queue, and then the agents start to go to work on it. So the agents are there's an analyst agent that takes a look at it and determines what kind of project is it, and then says, okay, whatever team it is that needs to be involved with this team needs to have these skill sets. Here's the background. If there's a company that's involved, it'll go out and it'll do research on the company. It'll say, here's the company that's involved. This is it a public or a private company? Is it a nonprofit? Does it have how many employees does it have? These types of things. What is the financial situation? Is it venture funded? All these types of things. And it'll provide that information to the master agent, which then builds out a team in parallel based on how many number of phases, right? So if there's a three-phase uh, project, it'll build out three teams. And the teams consist of your creator agent, what we call a pod agent, and a reviewer or a team of reviewers, depending on whether or not there are issues. So the pod agent takes a look at all that information, all that context, all of what's provided by the master agents and so on and so forth, and then um, uh, gives answers in a structured output. We use JSON and say, okay, provide this in a JSON format. And so then it provides all that information. Then the reviewer takes a look at that and says, okay, and it compares it to the contract. I forgot to mention, the master agent creates a contract based on what it thinks needs to happen in order to have success with this particular plan. And so then the reviewer compares what the answers are to the contract and holds the pod agent accountable to that contract. Now, what we used to do is we used to say, okay, well, let's say the reviewer doesn't like what's going on with and the contract isn't fulfilled, then basically it would kick it back to the creative agent in order to give it another go. What we've determined instead that works better is just have the reviewer fix the issue. Because these things are so objective about it, the reviewer knows exactly what needs to be fixed. Just go ahead and fix it. And oh, by the way, now that you've fixed this, now that you've touched it, you've made a change to it, you haven't approved it, go ahead and tack another reviewer onto the end of it, so that you can um, uh, make sure that contract is fulfilled. So then this goes to a number of iterations that is defined by the process. And then if in the event that it exceeds that number, like for example, 3 or 10 or whatever, then essentially it gets escalated to the master agent, and the master agent makes the final decision. Then from there, the whole thing is created in Monday.com. So here's an example. So basically, this is the front end of it. Is essentially we put the product requirements document in here, and here's an example, and then get it going. And I'll show you. I'll start this off, but it takes quite a while. So we'll kind of move on from doing that. Um, and just go straight to the finished board, because it takes between 30 and 30 minutes and 60 minutes in order to get things handled. So give me just a second here.
But it is real. It does work.
It's real. It is real. It does work. It does produce actual project plans. And this project plan that I'm going to show you is an example but we have actually been using it in production. Okay, so grab this, and so we're going to put it in here. So this is the PRD for this particular example. Then we go to generate the project board. It says, hey, it started, and it's waiting for a worker, and now the agents get to work, right? So I'm going to take a look at the log. And basically at this point, then it goes through that whole process where it's going to instantiate the master agent, the analyst agent, the pod agents, and all that type of stuff. And it's going to take a while. But the finished product then, after all of that, here's an example of one, is essentially it structures the tasks, it provides the effort associated with it, it provides the timeline associated with it, it gives the dependencies, so you can create a full Gantt chart. So it takes a template from Monday.com, and all of this is generated by that team of AI agents. Then every single task has a description in it that provides a bunch of helpful information. So it gives a deeper description of each individual task, acceptance criteria, key goals, risks and mitigation, and some resources that are checked. So the resources are verified as valid resources by the agent team, and then an implementation checklist. So every single one of these tasks has this additional information. So there's an example of an agent team working to provide, actually, then we use these project plans in helping our clients with their projects. Now we also have another one that creates the proposal for them as well. So we take that same product requirements document, right? And then we put that into what I call the SOW-O-matic. And then that then creates a full proposal associated with that as well. All right, that's everything that we had. And I just wanted to mention we're gonna open it up for Q&A now, but just to share, so you have the link in the chat if you need one assistance. You can also mail sales at bluewavegroup.com. If you have any questions for me after this, so let's get to the Q&A, John.
Um, okay, there's been a number of good questions that have just been answered, or asked
Sure.
and answered. But one of the things that the last question just came in, because we've been using it internally here. So why don't we talk about what it took to integrate the core platforms and what we needed, what we had to look out for to make sure the links are reliable, and address that to fill that gap.
Um, Give me more context of that one.
Well, how did we integrate ConnectWise and Outlook and
Oh
Teams?
yeah, so what are the building blocks for that? Sure.
Yeah.
So basically AI models are great at dealing with APIs. So what we did was we took um, there is and by the way, API is application programming interface. It's essentially a programming set of um, endpoints that anybody can hit out there with the correct authentication and get things done within their system, right? So basically, we fed the whole schema of that into the AI agent with instructions to say, this is the information about how to access the system, and then documentation that is provided also about how to do the certain things that we want to do, like for example, updating a sales opportunity. And then we asked the AI agent to do it initially. So essentially, what wound up happening was it got some of it right and it got some of it wrong. And so then that's where the prompting comes in to say, okay, in order to accomplish this particular task, so let's say for example, creating an activity. In order to create an activity, you're going to do this step, this step, this step, and this step. I'll give you a particular example. So you see here how this Monday board, how these groupings, the way that Monday does things for whatever reason is they actually do it backwards. So what you have to do is you don't build the project plan from the API in um first to last. You actually build it from last to first. And then it shows up the way that we're looking at it the correct way. So we had to, because understandably, the AI is going to go, I'm going to do the first phase first and the second phase second. Nope, that's wrong. It gets it backwards that way. So we have to train the AI, provide the instructions to the AI to say, do it in the reverse order. So we have it create a document, say, go ahead and follow this document when you're creating the board, and then that was really all that was needed was to have it reverse the order. So basically we're giving it now. There's another option that you have, and we were going to talk about this, but we didn't actually. We didn't actually have the time to talk about this, but since you brought it up in the question, the other one is model context protocol. So uh, around last year, 2020, or actually a little bit over a year ago, 2024, Anthropic introduced model context protocol. And basically, what that was the ability to hand an AI model tools in order to create an agent. Now, the reason why, and we started out with model context protocol, but we kind of moved away from it because what we learned quickly was that the model context protocol is just a wrapper around the API. So just go to the API directly. The model's really good at it. And the model context protocol really doesn't do anything for you, except for if you're building your own, except for if you want to add a tool to a model that somebody else has built, it's a great way to do it. So what we do is tools that somebody else has built, if they don't have an API for it, then that's a great example for a model context protocol tool or MCP tool. So we do have some of them are connected via MCP, but more and more, if we can, we just go direct to the API. Like we're working with Monday, we're working direct with the Monday API. With ConnectWise, we're working direct with the ConnectWise API because it just takes out that extra layer that's not really necessary. Now, also, there's another one that's called Context 7. So if I can go there. Context 7. Context 7, if you haven't heard about it, is a great tool to help AI models get information about things that they're trying to work with. Like, for example, somebody who brought up Crew AI. You can say in here, I want to look for the Crew AI. I want to look for the Crew AI documentation, and it does this. Well, they have a model context protocol server for Context 7, which I use all the time, and I highly recommend it because it really helps models get to what it is that they're looking that they're looking for, get to the documentation that they're looking for.
Cool.
Other
Do you want to talk about how we've been using Markdown documents on moving data and having the AI summarize what we did so we can go back and improve the interface?
Yeah, sure. So, what we have determined is uh, the documentation that we use as humans, like that we're used to, like Word documents, Excel documents, PDFs, and stuff like this. AI models don't like that. They can work with them, and if you put a document into ChatGPT and whatnot, it'll figure out, okay, this is because this is what we work with, right? So we're kind of like forcing the model into that space. And then on the flip side, models really like JSON. Like we were saying, we use JSON for the structured output. Models really like JSON. Well, we hate JSON. JSON is terrible. We can't, it's difficult for us to read and stuff. And in fact, what we do is, do things to make it so it's prettier for us so we can understand it. Well, what actually works is Markdown. Markdown, both humans and AI models can understand. So, for example, this is a Markdown document, and if I let's see, if I just drag one in here, and you may have seen this before, but basically the raw version of it looks like this, right? So it's got a little bit of stuff in it, but it's readable to us, and we can work with it. Now, I have a formatter in Chrome that's called Markdown Viewer, I think is what it's called. That basically, if I do a refresh on this, you'll see that familiar view. And so now this is much easier for me to look at, right? So I can edit the document, and it's just a text file with some formatting associated with it. And what we found is that Markdown documents are great for humans and AI to collaborate together. So the recommendation from us is if you're going to be working with AI agents, get everything that you can to Markdown because both of us can understand it. It's a good common middle ground. And I don't have an example of this, but basically it has all kinds of capabilities like you can show formatted code with it. You can have the mermaid diagrams and things along. It'll render all of that in the Markdown document, and it also handles links, right? Because that's the other thing is that links get lost in some formats. It'll handle links very well, and so we found that Markdown is a great middle ground between AI and human.
Okay. Another really good question that you should definitely consider and answer is how do you protect company data in terms of API keys? How do we protect that? Security, access control, auditability, and prevent data leakage.
Sure. So, um, protecting the information and things like that. Essentially, what you work on with as far as agents is concerned is you have a vault and you use secrets. So the AI agent doesn't actually provide doesn't actually get the key and you provide the key to the agent. What happens is it gets the secret from the vault. So it accesses the vault. It doesn't know what the key is. It puts the key into the request for the API without knowing what it is. And then from there, the API handles and gets the information and gets it back. So that way, the agent can use the tool, and your key isn't affected by it. And I think there were a couple of other that your data. So in terms of your data, that is an there's a couple of different options for that, right? So you can obviously the local models are now getting good enough to where companies are essentially having the models local, particularly for agents, because probably what you would do is you'd have a planner use one of the major models like the GPTs and the Geminis and whatnot there's no way you're going to have the infrastructure for that. But then if you're going to hand it off to an agent, you could probably deal with a smaller model that you run on a decent piece of hardware and goes and executes the actions, right? So if you think of like Gemini Flash, right? Basically, there's other models that you can run locally, like that GLM 47. That's a model that's available to run locally, and another one was GPT OSS. So GPT OpenAI released GPT OSS a little bit less than a year ago, where essentially models like that are able to handle the execution actions, and then that'll help protect the information as well.
Sounds good. I think the only other question, which would actually be probably a whole seminar on itself, is how we built our stack and how it works. But that would be an hour-long process just by itself.
Sure. So how we built our stack, I can go into, you're right. I can go into a little bit of detail about that. And then, if again, just a reminder, if you'd like help, you can scan the code here or in the chat, click on the link and we can get you some help. But how we built the project agency is using Pydantic AI and LangChain and LangGraph, as well as um, uh, basically some um, other, I guess some other typing without going into too much detail. Basically, some things that deal with the constraints, and putting in the guardrails, and we're focusing our attention on how do we get from the model specifically what it is that we're looking for, right? So essentially in the prompting, providing specific prompting to the models to say, okay, you need to provide this particular output. And then if they don't have that output, kicking it right back to them with instructions and this comes from Pydantic AI, with instructions to help guide them to say, okay, in order to get past this gate, you have to do these things, right? And we found that to be very effective. And so essentially what you can do is you can uh, 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 kind of like a soft bounce, right? Where basically the model tries something and the information from the system comes back to the model to say, okay, well, you got this, and this right, but this is wrong, and here's how to make it better. So then the model can do another try again. And we've seen this with the models. To give you an example of kind of how it works with our ConnectWise CRM system, is until we put together a document that specifically states this is how it is. Because a lot of times you're going to explore, what it is that you want to do when you're working with the system, right? So, we'll try things that we've never tried before, and we'll see if the model can do it, right? So what you'll see the model try something, fail, try, fail, try, fail, try, fail, try, fail, try, fail, succeed. And then basically you say, okay, we'll make a note on that. That's how you do that. And so then the next time around, it goes through that. I'll give you an example. There in the Microsoft space, there's a couple of different options for getting mail. And what models will often do is they'll use what's known as the me endpoint. Well, the me endpoint doesn't work with certain types of getting certain types of information. And so we had to direct the model to use the actual email address of the person, like, for example, gwallin at bluwavegroup.com. So we had to create a document to that because the first time that it would do it is it would always use that, it would always wanted to use that endpoint. No matter what we did, it would always start out like that until we said, okay, follow this document. Like no model is going to figure out, even if we give it the information, no model figures out that this is what needs to do. So it needs to have a process to say, okay, follow these steps, right? Follow this workflow. One, two, three, four, five. The first step is don't use me. Use the email address, and so what we would have at the start is we would have the model would basically say, I can't do this. And you're like, no, no, you can do it. You did it before, right? We had success before. Refer to that. Okay. So then it would say, okay, I remember what I did, and then it would make the correct move. And it's okay, great. Now, and here's a pro tip. When you're done with getting what you want, tell the model, okay, now reverse engineer what it is that we did here so that we get the right result the first time. And it'll say, okay, and it'll go through process and say, here's the prompt that you need for the next time around. And so then we'll feed that into the system, and the next time around we'll get a much better result.
Yep. Thank you, everybody, for attending. It's a few minutes to the top of the hour. This has been recorded and will be available, and the slides will be available as well. So we want to make sure you guys have the information at your fingertips when you need it. Any other closing comments or questions? Feel free to ask. We'll be online for a
John,
few
I want
minutes.
to add real quick. Please use our live chat on our website.
That's a good point.
Yep, feel free to after we end here, you can if you want to continue chatting, feel free to go to the website, and then which is bluwavegroup.com, and then there's a chat session there, and that's available for you.
Cool.
All
I
right.
I think we're good.
Awesome. Well, thank you, everyone. We appreciate you joining us today, and good luck with your AI endeavors, and have a wonderful week.
Thank you, everybody.